Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I am Matt Miller. Dr. Brad Tucker is here. Brad, happy Tuesday.
How's it going?
Doing really well, my friend. Let's get the headlines in the 50th week of 2021. Nissan is teaming up with the Japanese Space Agency to build a Lunar Rover. A new space manufacturing hub has been announced for Adelaide. And NASA's latest telescope set to study black holes.
This is Trekzone's Talkin Science.
Well, don't forget Trekzone membership available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. Brad, too, on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook. Brad, it's our last regular show of the season after producing a Talkin Science every Tuesday since February the 2nd. An incredible achievement. One I am so appreciative that you support each and every week. Next week, I'll take the show and then we'll have a look back at the year that was. For you, though, what's been a standout story of the year?
Look, I would say because of what it means for how we access space, that is all of the companies launching private people into space for the first time. It was only in July. I know it seems like 8 years ago, but it was, 5 months ago. And I think that's the remarkable thing, that we've had 3 Blue Origin flights, a SpaceX flight, Virgin Galactic, all sending private people up into space for the first time, something that we've been waiting decades for, and we've now seen it multiple times this year. And I think that's probably the biggest thing that's changed the way we interact in space.
Yeah, absolutely. Well, let's get into the show. The James Webb telescope is set to be launched next week, with Tidbinbilla tipped to provide the first contact with it once it reaches orbit.
Yeah, look, obviously something we've been waiting for decades, and most recently for over a year, to get this thing launched. And it's exciting to see that it is scheduled for launch just like a week from now, about 8 days, 8 days. And it has a long journey into space. Until it gets ready, but we're looking forward to it being turned on.
Absolutely. A team of scientists, Brad, are working on a Smelly propellant for satellites. They reckon the key ingredient in mothballs can be used as a cheap fuel, which would allow up to 20% lifespan increases, Brad.
So yeah, this is kind of exciting, because one of the things that we want is fuel that is lightweight and dense, and that's where you can get some ethylene from the ingredient in mothballs. One of the exciting things is when you heat mothballs at 70 degrees Celsius, it goes from a solid to gas. It doesn't really turn into a liquid. And that's great, because obviously in satellites, you don't want your gas system to have a bunch of liquid or condensed, because that's not good. Things tend to break and explode. And at 70 degrees Celsius, it's not that hot. So yeah, all of these things are great, because it gives us a great chance to have a good fuel source. And as you said, if it works, will it give a satellite its lifetime by about 20%, which is 1 to 2 years, depending on the lifetime. But that's actually a big deal in terms of cost and work.
Yeah, it absolutely is an incredible one. Well, let's keep moving. Last year, the Japanese Space Agency and Honda joined forces to test a new circulative renewable energy system. Now the Space Agency has signed up with Nissan to build a Lunar Rover, Brad.
Yeah, I think that's kind of cool, because we talk a lot about the US in particular and Australia when they're private industries in space, but Australia or Japan is doing it really well. And Japan is planning its own mission to the moon in a couple of years, maybe late next 2023 or 2024, and they want a rover as part of it. Now, when we think of driving on the moon, I think we just kind of drive or picture driving in dirt, but it's actually really tricky. The lunar dust, the regolith, is so fine. It's finer than sand. So it's actually not that easy to drive in. So by partnering with Nissan, it's actually kind of a cool idea of developing a new drive system, essentially, for the lunar surface, and working with a group that kind of knows how to build cars. I think that's kind of the great idea of this mixing of industries, is you don't have to invent everything yourself. There may be someone else who's thought of it before you, and lo and behold, car manufacturers may be a good group.
Exactly right. Well, they've been working together since January 2020. The car maker says research and development here will power its next generation electric vehicles. One of those technologies is e-Force. It's a technology they're developing which will enable all-wheel drive control in the microgravity conditions, and that can be adapted to Earth-based vehicles as well with that precise four-wheel control. It really is another one of these build it for space and use it on Earth scenarios, Brad.
Yeah, and that's exactly right. Because if you can drive on the moon, well, you could probably have cool ways of driving on Earth. That's the thing, obviously it's extreme four-wheel driving. Every wheel needs to be independent, and the grid works different. So if they can carry over that technology to better systems of driving on Earth, I think that's a win-win. So again, it's one of these interesting benefits that we see from the merging of these industries is that we have a better way of doing things and probably more efficient and economical way of doing it in space. And then we get the benefits and the propagation of those technologies here on Earth. So again, I think it's a beautiful example of what you can happen, and one that we should consider when Australia builds its own moon rover, looking at a lot of these other industries, maybe who wouldn't normally be in the space game about how they can assist in these goals.
Well, Brad, with Honda providing the energy system, Nissan the Rover, what other collaborations could there be? We're talking about Australia here as well. Other industries, some not necessarily even thought of in the space industry, as you're saying. I'm trying to think if Toyota can get involved. Hyundai, maybe we could do, people movers on the moon. We might need them.
Well, you could, but there's a lot. I think where a lot of Australia points to is the autonomous nature of our vehicles, right? That's the benefit we have when you're talking about mining. The largest autonomous train in the Pilbara. All of that stuff is remotely operated, which is exactly what you need to do on the lunar surface. So we have an edge up, and that's again one thing that people keep pointing to is we have this whole industry here where we don't have to reinvent the wheel. If you've managed to do it in the Pilbara, you can manage to do it on the moon. And so I think that's an exciting thing. It's all about using your strengths and what you have to your advantage. And lots of countries are now getting good at saying, all right, this is what industries do we have, who can benefit from it, but also who can aid these missions. And it just becomes cheaper in the long run. It develops a workforce. All of these buzzwords people throw out, it's actually the way to do it instead of trying to invest heavily in one group to build the expertise when the expertise may already be sitting there in another sector.
Yeah, exactly right. Well, next up, the first dedicated space manufacturing hub has been announced for Adelaide, Brad.
Yeah, this is kind of that perfect example. One of these ideas that how do we get critical mass when we're developing satellites and technology? And part of that is making sure you have enough groups with enough technology and enough skill sets to pull off these missions. In any mission, no matter what it is, no one group really does everything. Even in NASA does it. Different parts of NASA do different parts of the mission. And this idea here is if one building, one hub, one center can pull it all together, well, then you can improve the way and streamline and then aim for bigger projects, right? And so instead of saying, all right, well, I got this idea, but I need to go over to this place for that part, this place for that part, you can go to a one-stop shop, so to speak, and those groups can work together and coordinate.
Well, initially, the purpose-built facility will bring together Fleet Space Technologies, Q Control, AT Space, and Alauda Aeronautics, alongside Mission Control and Agency headquarters in the South Australian capital. Certainly the place to be if you want to work in our space industry, Brad.
So yeah, when you look at these models in the US, again, you see even when you get the NASA centers, you get a whole bunch of private companies on the campuses or the bases. You go to NASA Ames, where I used to spend a lot of my time with Kepler, and there's 10, 12 other different companies from startups to bigger groups. When you go to when you look at Johnson Space Center, Kennedy, Boeing and Lockheed Martin are sitting right there as well. The fact that they're all next to each other and kind of neighbors just means it's easier to do business and trade. And especially if you're building big components that need to be transported or assembled in different groups, you don't want to ship it halfway across the country. It's nice to just move it next door. Very simple.
Exactly. Well, the current forecast growth rate of the sector here in Australia is 5.8% over the next decade. That's an incredible amount of progress to be made. So, laying groundwork like these massive hubs is key, Brad. As you say, this is what America's doing. They've been doing it for 60 years. Time that Australia did it, and we're doing it in sleepy old Adelaide.
And it's about attracting other people as well. It's not saying, hey, we're just going to have these four. These four can bring in other groups, and that's what it's about. It's getting more investment, more groups, more interest, and then you just build bigger projects. It is kind of that simple. It doesn't seem like it should be, but if there's enough people to do enough things, but then you also get the secondary industries. You get people who build parts and equipment that are used by those groups. So then they want to be around. So you really develop an industry rather than a company.
Well, lastly this week, IXPE, the Imaging X-ray Telemetry Explorer, has been launched, and it's going to give us a new appreciation for the X-rays released by black holes and neutron stars, Brad.
Yeah, this is kind of looking at things that are big energy factories, things that generate huge amounts of energy and spew it or shoot it out through space. The idea here is that, especially in black holes, but also neutron stars, these are very energetic, usually very magnetic as well. There's lots of magnetism around areas that shoot out particles. And when they zap it, they shoot it, they are shot out or released at the highest energies. The highest energies here are X-rays. So, X-rays are the really highest energy, and then you got ultraviolet. That's why we get burnt in radiation, same with X-rays. And then we go to optical and infrared and radio, which isn't as dangerous. So X-rays are very energetic, but it also means you need a special telescope to look at it, and one outside the Earth, because luckily our Earth's atmosphere blocks those X-rays, because although we're bombarded with X-ray radiation all the time, and well, we wouldn't be here having this chat and building this telescope. So you have to put these in space, but also we need to study what is happening at the center of these black holes and neutron stars and other things to figuring out what is causing and how this energy is generated.
Well, this one's a joint effort between NASA and the Italian Space Agency. Now, there's an agency we don't hear too much from. While the telescope isn't as big as the Chandra X-ray Observatory, it does have this unique mission in mind, Brad.
Yeah, it's complementary, and that's again one of these things that we're starting to see is you don't need a mission that is big the thing. It's cheaper to build a little bit more specialized and a little bit more special, kitted out experiments on these things. And the Italian Space Agency does do things usually as part of ESA, but now they're able to directly partner at kind of like an institution level between the Italian Space Agency and NASA to pull off these missions. And we're starting to see this. They have another one as well in the works with the Lucy mission. The Italian Space Agency built two of the CubeSats that are attached to Lucy, headed out to the asteroid. Sorry, the DART mission, not Lucy. The DART mission is going to crash into the asteroids, and before the probe gets there, the Italian CubeSats will hop off and watch it. So, it's again just one of these things. There's so many different people that the different combinations of partners means you don't have to wait to build a big mission because there's only one. So you kind of have to put all of your eggs in one basket. You can diversify a bit and have different groups doing different things.
Well, IXPE is going to help us understand the remnants of exploded stars and their environments, hopefully confirming theories about the universe, Brad, or better yet, shaking them up and making us think about new things.
Yeah, look, that's always the nice thing when you have a new telescope is you'll find new things. We'll find new objects that we hadn't seen or new processes, and that's one of the things just about looking in a new way. It's like when you get a new channel on the television. Well, you'll find a new show potentially that you've never seen before. And this is the exact idea is we will see the way black holes, neutron stars, exploding stars all behave in different light and in a different way of measuring that light. So we'll get confirmations of theories that we've always thought, and we'll obviously have to develop new theories or new ideas. And then we'll just have the surprises. And that's always a nice, exciting thing. And, all of the talk on the James Webb Space Telescope, well, we have another new telescope to play with all at the same time.
It's very exciting times. Well, I spoke about the accumulation of data with PhD student Jennifer Hardwick on Talkin Science recently. She's working on Arecibo data from 2017. IXPE will provide the same repository of information as well, won't it, Brad, for years to come?
Yeah, all of these space missions, you kind of catalog it, and then if you find a new object or you find a new understanding, you can kind of go back and look and say, oh, that's what that is, or this is what it looks like. We are still using the Kepler Space Telescope, even though it's been shut off for a couple of years, looking at data 8 years ago now, almost in some cases. Just because the mission is over doesn't mean that's when the science stops. It means that you probably actually do even more science because you've learned new things and you can go back and revisit it, or you can have new ideas based on what you find and then reanalyze it. So, and then as you get new missions, you can kind of combine it together. So, there are people who make careers off of old data, so to speak, mining and looking at previous data because there's still a lot of science and understanding to go in these missions.
Well, just before we go, Brad, a look ahead to this week's Talkin' Science interview. Dr. Lily Sun is beaming in to discuss the hunt for boson particles, those missing links in dark matter, and how gravitational waves can be our key to finding them. Why we're so curious to find them?
Yeah, okay. This is a very interesting study, actually. As many of you might know that we have been looking for gravitational waves from the collisions of black hole, neutron star binaries. So, but actually these are not the only types of gravitational waves we are looking for. There are other types of gravitational waves and they are all very interesting. And the boson clouds are potentially one out of the many potential sources out there. These clouds are made up of ultralight boson particles if they exist. So these particles have not yet been detected. They are so far being predicted by series. They are ultralight. I'm not sure, it's really hard to imagine, they have the mass around 10 to the minus 28 kilogram, something like that. So they barely interact with matter, and they also could potentially be an important component of dark matter.
Well, members have first play access to that interview right now. Sign up with the join button below this video on YouTube or go to the trek.zone/support. Brad, it's great to pick apart the stories of the week with you. Thank you for 46 weeks of Talkin' Science this year, my friend. We'll see you again for our New Year's special in 2 weeks' time. Have a good Chrissy.
Thanks.
Bye.